This video tutorial I will explain Apache Kafka architecture. Here you can see Kafka ecosystem. Kafka ecosystem has Kafka cluster which has multiple brokers, and here you can see the producers which push the message to the Kafka topic, and here you can see the consumer group which has multiple consumers, and consumers pull message from Kafka topic, and here you can see the ZooKeeper which manage the Kafka ecosystem. Here you can see Kafka cluster. It has multiple brokers. To maintain load balance, Kafka cluster consists of multiple brokers. However, these brokers are stateless. So to maintain cluster state, we have to use ZooKeeper. And one Kafka broker instance can handle hundreds of thousands of reads and writes per second. And without performance impact, each broker can handle terabytes of messages, and ZooKeeper performs Kafka broker leader election. Here you can see the ZooKeeper. For the purpose of managing and coordinating, Kafka broker uses ZooKeeper. Whenever a new broker added to the Kafka system, or any broker fails in the Kafka system, then ZooKeeper will send notification to producers and consumers. As soon as ZooKeeper sends the notification regarding the presence of new broker in the Kafka system or failure of the broker in the Kafka system, then producer and consumer take the decision and starts coordinating their task with some other broker. Here you can see the Kafka producers. Kafka producers push the message to the Kafka brokers. Also, all the producers search it and automatically send a message to that new broker exactly when the new broker starts. And Kafka producer send the messages as fast as the broker can handle. And Kafka producer does not wait for acknowledgements from the Kafka broker. Here you can see consumer group. It has multiple consumers. Consumer pull the message from Kafka brokers. Basically, by using a partition offset, the Kafka consumer maintains how many messages have been consumed, because Kafka brokers are stateless. Moreover, you can assure that consumer has consumed all prior messages once consumer acknowledges a particular message offset. Now we will see consumer group. Here you can see consumer group. It has three consumers. So consumer group can have multiple consumer instance running, and basically one consumer group will have one unique group ID. At the time of reading, exactly one consumer instance read data from one partition in one consumer group. Here you can see three consumers. Consumer 1 reads data from partition 0, consumer 2 reads data from partition 1, consumer 3 reads data from partition 2. So each consumer reads data from different partitions. There is a possibility of more than one consumer group. In that case, one consumer instance from each of these groups can read data from one single partition. If the number of consumers exceeds the number of partitions, then there is a possibility of some inactive consumers. Suppose say in the consumer group there are 8 consumers and 6 partitions. That means there will be 2 inactive consumers. Now we will see Kafka topics and relationship between Kafka topics and partitions. Here you can see the topic. It has 3 partitions: partition 0, partition 1 and partition 2. So topic may contain any number of partitions, and messages are written to the topics, and Kafka randomly selects which partition the message to be written, and this is the old message and this is the new message, and partition wise offset will increment. Topic is nothing but a logical channel to which producers publish the messages, and from the topic the consumers receive the messages, and topic defines stream of particular type or classification of data, and here messages are structured or organized, and a particular type of messages is published on the particular topic. Suppose say the topic name is animal, then animal related messages are published to the animal topic. Suppose say the topic name is food, then food related messages are published to the food topic. First, producer writes its messages to the topics, and from the topics, consumer read those messages. And in Kafka cluster, topic is identified by topic name, and the topic name must be unique. And there can be any number of topics. There is no limitation, and we cannot change or update the data as soon as the data gets published. In Kafka cluster, topics are split into partitions, and these partitions also replicated across the brokers, and there is no guarantee in which partition the published message will be written. Also, we can add a key to the message. Basically, we will get ensured all these messages with the same key will publish to the same partition if producer publish the message with the key. Due to this feature, Kafka offers message sequencing guarantee. And suppose the message does not have the key, then data is returned to the partitions in random manner. In one partition, messages are stored in the sequenced fashion. In a partition, each message is assigned to an incremental ID that is called offset. And within the partition, these offsets are meaningful. And there can be any number of partitions. There is no limitation. Now we will see topic replication factor in Kafka. Here you can see broker 1. It has topic A partition 0. Replication of this topic A partition 0 is in broker 2, and in broker 2 topic A partition 1 is there. Replication of topic A partition 1 is there in broker 3, and in broker 3 topic B partition 1 is there. Replication of this topic B partition 1 is there in broker 1. The green color is the leader, and the yellow color is the replicas. Suppose say this broker 1 is crashed. In this situation, partition 0 of topic A of broker 1 is not available, but its replica is available in broker 2. So this replica will become leader, and after that any messages published to partition 0 of topic A will be handled by this one. Replication takes place in the partition level only. For the given partition, only one broker can be the leader at a time. Meanwhile, other brokers will have in-sync replicas, and it is not possible to have the number of replication factor more than the number of available brokers.
You can get Java source code link for each video from the description section of the video. And here you can see the video, and to see the description, click on this more, and here you can see the description, and here you can see the links, and click on these links to get the Java source code.